doctor, and he said that I've got this problem. The doctor said, I've got a good news for you and I've got a bad news for you. He said, the bad news first, that you've got a very chronic disease, you have to undergo operation, and the survival chances out of that operation is 1 in 100. Now this person got worried, concerned, 1 in 100 is the survival chance. He started crying. He said, wait. There's a good part to it as well. In your case, it is going to be 100% cure. He said, how can you be so sure? He said, because I have performed 99 operations before and all of them have died. You are the 100th one, so you will definitely survive. That he is abusing probability. It doesn't mean 1 in 100 doesn't mean that if 100 operations are performed, 99 would be, would be fatal and 1 would definitely survive. It simply means that if infinite and you ask me, does Mr. X belong to the set of tall people? You cannot say yes, you cannot say no either. There is a certain degree of belongingness. That yes, he belongs to the set of tall people to a degree 0.7. And he doesn't belong to the set of tall people to a degree 0.3. If I ask you, does Albert Einstein belong to the set of intelligent people? You cannot say that absolutely he belongs there. He must have done some stupidity in his life. So you can say that, well, he belongs to the set of intelligent people to a high degree, but to a certain finite degree he doesn't belong to the set of intelligent people. So our perception of our sensors that we have got in brain, they work on imprecision. If I tell anybody of you to take a few steps forward, as human beings you can understand what do I mean by a few. You can actually translate it to 4, 5, 6 steps. But if I tell a machine or a computer to take few steps and loop back, the computer will miserably fail. I don't understand what you mean by a few steps. You need to tell me precisely. So precision is required in computation, whereas by nature, all of us as human beings are imprecise. Okay? Let me give you another pointed example. If I ask you a question, or let me put it like this, is 5 equal to 5? You will say yes. So it assumes a truth value of 1. If I ask you, is 4 equal to 5? You will say no, a truth value of 0, which means completely false. Now I ask you again, is 3 equal to 5? You will say no again, and the truth value of 0 again, completely false. Now the argument is, doesn't 4 belong to 5 holds a higher truth value than 3 equal to 5? Or in other words, shouldn't 3 equal to 5 be more false than 4 equal to 5? That is where the fuzzy logic sets its course apart. Let me make it more close. When you say 5 equal to 5, yes. 4.9999 equal to 5, you say no. Does that make sense? Similarly, 5.00001, you say it is false, is not equal to 5. So that is where fuzzy logic has got the sense of degree of belongingness to a certain degree. If somebody asks me, is today a warm day? You can say yes to a certain degree, and that varies, that is subjective, varies from person to person. If you have to take a decision whether to take the umbrella or not, you have to analyze whether the day is cloudy or not. Now cloudiness is again a vague term. How thick are the clouds? How dark are the clouds? How close are the clouds? All that adds to the degree of cloudiness. So intelligence, height, beauty, warmth, and every physical parameter that you talk about, that involves the sense of degree of belongingness. If I take you closer to, say, the practical aspects of fuzzy logic, you must have heard of fuzzy logic enabled washing machines. Now what is fuzzy logic doing in a washing machine? If you ask me to wash my linen, in a washing machine, I have to decide what wash cycle do I have to choose, what is the time duration I have to put the spin cycle, how much water has to be added, how much detergent has to be added, and all the decisions are on me. If I've got a fuzzy logic enabled washing machine, I can speak to the washing machine in words. So fuzzy logic in that sense leads to computing with words rather than computing with numbers. You tell the washing machine that my linen are reasonably soft. It has got a high degree of dirt in it, and I want it reasonably clean. So those qualifiers, reasonably clean, pretty soft and very dirty, all that must be translated ultimately to the amount of detergent, to the wash cycle, to the amount of water, to the temperature of water, and all things that are required. So that long bridge that has to be established in the gap from computing with words to computing with numbers. If I tell you most sweets are tall, and then I ask you what is the average height of a sweet, as human beings, I can have the perception that most sweets are tall, then average height must be like 6 feet. But if you ask a computer, most sweets are tall, what is the average height of a sweet? He'll say, I don't know. What do you mean? What are you asking? Okay. So as human beings, we are able to perceive a lot of things in words, and fuzzy logic enables us to compute with words rather than with numbers. Okay. So our perception, subjectivity, the vagueness that is surrounding all of us can either be countered by the probability theory or can be countered by fuzzy logic. And both of them, they have to go, they are not competitive to each other, rather they augment each other to counter the broad area of vagueness, which could be classified into either the certainty part of it or the imprecision part of it. Thank you very much.